Hi, calculus students. These notes are on curve sketching. This curve sketching is something we've done from graphs way back when, but now we're going to kind of think about how can we do the same process, but given an equation of a function and putting together the first and second derivative tests. So one thing we'll kind of quickly review is kind of like what are the different shapes of curves we could have. So if you recall, we kind of thought about like if the first derivative is positive, the second derivative is say positive, what would the shape of the curve be on that interval? So we would say like the positive second derivative is telling us concave up and positive first derivative is telling us increasing. So we get something like that. If the first derivative is positive and the second derivative is negative, now it's concave down and increasing. That would look like that. First derivative negative, second derivative positive means decreasing and concave up. You look like that. And lastly, first derivative negative, second derivative negative would be decreasing and concave down. And it would look something like this. So as we think about curve sketching, we're putting together the first and second derivative test to get, for a specific interval, what shape will the curve be. And then we're kind of piecing together all those shapes to sketch a curve. So I'm going to show you one example and give you a problem to try. So my example is going to be f of x equals x to the fourth minus 4x to the third plus 3. And so the idea here is we want to do the first and second derivative test. So the first thing we're going to do is find the first and second derivative. So for f prime, we get 4x to the third minus 12x squared. The 3 goes away. And then for my second derivative, we get 12x squared minus 24x. Okay? Now we have our first and second derivative. I'm going to do my two derivative tests. So I need to find critical points and create a number line. Okay? So I'll say find critical points. So that means let's set f prime equal to 0. I can factor out a GCF of 4x squared. What's left is x minus 3. That means if I set 4x squared equal to 0, I get x equals 0. And if I set x minus 3 equal to 0, I get x equals 3. So this gives me my two critical points for my first derivative test. And I'm going to do the same process with my second derivative. So there's a GCF here as well. It's 12x. What's left is x minus 2. So when I set each of those equal to 0, I get x equals 0 or x equals 2. Now notice one of these critical points is the same for both, 0. Okay, so this is something we have done in the past where we're putting both the first and second derivative tests on the same signed number line. So the next step is going to be to create that number line or sign chart, however you want to call it. And the way I'm going to do that is I'm actually going to put all of the critical points from both the first and second derivative tests on the same number line. So I'm going to have 0, 2, and 3. And I want to think about f double prime, f prime, and f. Okay? Now, one thing to kind of be aware of is for f double prime, I only need to check the critical, kind of like the change in sign at 0 or at 2. Right? So I'm really only considering like what's happening here, and then this whole thing should be the same. And then for the first derivative, I'm just considering 0 and 3. So like this is I have to think about for both. And then I would just think about the barrier at 3 when I'm doing this row. Okay, so let's see what happens. So it doesn't matter where you start. I might as well start at the bottom and work my way up. So for the second derivative, I can think about when we're less than 0, plugging in here, say -1, this is negative, and if I plug in -1, this is also negative, so I get something positive. when I plug in something on this interval between 0 and 2, I'm going to plug in, say, 1. I'm going to get positive and then negative. So that puts this at negative. And between 2 and 3, say 2.5, this would be positive. And 2.5 minus 2 would be positive. So we get positive. And then that positive also carries over beyond 3 because 3 wasn't even a critical point for my second derivative, so I don't have to check anything past 3 there. Okay, now we're going to do that same process for f prime. So f prime, looking up here, so I'm saying, say, plug in -1 for x squared is always going to be positive. So I could just always assume this term is positive because I'm squaring something. So then here, if I plug in -1, I get something negative. That means my first derivative is negative before 0. So now I'm plugging something in between 0 and 3, right? I don't need to worry about 2. I could even plug in 2 and see what happens, but I'm going to do 1. So positive, negative. So it makes this negative. And that also makes this interval negative since I'm really only caring about 0 and 3. Now I have to plug in something more than 3, so I'll plug in 4. And that gives me positive, positive. So we'll get a plus sign there. Okay, so now I have my signs of each first and second derivative. Now I'm going to put them all together to think about the shape of the curve on that interval. So this is where thinking about these 4 different shapes is useful. So checking this out, we have negative first derivative, positive second derivative. So that means concave up and decreasing. Looks like that. Between 0 and 2, we have decreasing and concave down. Should look like that. Between 2 and 3, we have decreasing and concave up. And then after 3, we have increasing and concave up. Okay, before I go to start sketching my curve, I'm going to think about what's happening at each of these critical points. So at 0, there's no change in sign of my first derivative. It's not a max or a min, but it is a point of inflection because my concavity changes. So I'm just going to label that POI, so I have that in mind. Then at 2, the change in sign of my second derivative, my first derivative doesn't change, so this is again a POI, point of inflection. And then at 3, no change in sign of second derivative, but there is a change in sign of my first derivative from negative to positive, decreasing to increasing, so that will be a minimum. Okay, so the last step in this process, you've actually done this before, is to plot our key points and sketch the curve. So one thing to keep in mind at this step is if I have an equation of the function, it's easy to find the y-intercept. And so in this case, you can imagine plugging in 0 for x and getting a y-intercept of 3. So since that's an easy point to know for sure is on my graph, I want to include that in my key points in addition to my critical points. Okay, so I know that the y, I'm just kind of making a note, y-intercept is at 3, and I'm going to make sure to include that on my curve. Okay, so going to sketch. Going to draw a coordinate plane. Everything, all the x values, the first x value I have here is 0, so I don't need so much of my negative axis. And I know that I want to have a point at 0, 3 for my y-intercept. So I'll put that on first. And that also takes care of what's happening here, right? That's going to be the point that I think about this changing over point, because that's where x equals 0. So I'm also going to make sure I get 2 and 3 on my coordinate plane. Okay, so now I'm going to place a point at 2, and I will need to think about, should it be placed higher or lower than the point I have at 0? Well, the function is looking like this. In between 0 and 2, it's decreasing, so I should put a point somewhere lower down. So I might as well put it there. And then between 2 and 3, I keep decreasing, so I'm going to put a point even lower than the point I had at 2, at 3. And then after 3, it's increasing, so I just need to make sure I kind of make a turn at that point. So now, what should I sketch? I'm basically, it's like connect the dots, but making sure I have each of these shapes. So before 0, it looks like this. Between 0 and 2, concave down and decreasing. Between 2 and 3, concave up and decreasing. And then at 3, increasing concave up. And we get a sketch of the curve. Okay, so we are primarily going to be doing this with polynomial functions, so we won't be dealing with as much tricky algebra as we have been, but it is a multi-step process and involves kind of synthesizing a lot of information. You try problem, and please do this one, so you get a sense of what you're understanding, is to sketch the following curve. F of x equals x to the third minus 6x squared plus 9x plus 1. And we will be discussing your solutions next time we meet for class.